Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU, Bhilai. In this tutorial, we discuss about time and space complexity analysis and application of data structure. Also, this is the last module of my course, Data Structure using C. So, in this tutorial, we cover what is time complexity, what is space complexity, what does it takes to develop a good algorithm, how significant are space and time complexity, what are asymptotic notations, best case, worst case and average case in asymptotic notations, or we can say analysis in notations part, significant in terms of space complexity, methods for calculating time and space complexity of the algorithms, and last we can discuss about the applications of data structure. So, in this tutorial you will explore computational complexity like space and time complexity, which is developed by Julius Hartmans and Richard E. Strain to assess the difficulty of an algorithm. As you all know, human nature strives to find the most efficient way to complete their daily task. The overarching, though, process behind innovations and technology is to make people's lives easier by providing solution to problem they may face. In the world of computer science and digital products, the same thing occurs. To perform better, you need to write algorithms that are time efficient and use less memory. An algorithm complexity is a nature of the amount of data that is must process in order to be efficient. Domain and range of the function are generally expressed in nature units. So, let us start with the introduction part of this complexity. So, you will learn about the computational complexity of the time and space complexity, a measure of algorithm difficulty defined by the Julius Hartmans and Richard. As you all are aware, it is a everyone inclination to look for the most effective manner to do daily activities. In the world of computer science and digital products, the same thing happens. The overarching ideas behind innovations and technology is to make people's lives easier by offering solution to problems they may face. You must create algorithms that are memory and time efficient if you want to perform better. So, the quantity of the data an algorithm must process to be effective in measured by its complexity. These functions, domains and range are often represented. So, first we understand the concept of time complexity. So, time complexity is defined in terms of how many times it takes to run a given algorithm based on the length of the input. Time complexity is not a measurement of how much time it takes to execute a particular algorithm, because such factors as programming language, operating system and processing power are also considered. So, time complexity is a type of computational complexity that describes the time required to execute an algorithm. The time complexity of an algorithm is the amount of time it takes for each statement to complete. As a result, it is highly dependent on the size of the processed data. It also adds to defining an algorithm effectiveness and evaluating its performance. Now, understand the concept of space complexity. When an algorithm is run on a computer, it necessitates a certain amount of memory space. The amount of memory used to program to execute it is represented by its space complexity. Because a program requires memory to store input data and temporal values while running. The space complexity is auxiliary and input space. So let's understand what does it takes to develop a good algorithm. So a good algorithm executes quickly and saves space in the process. You should find a happy medium of space and time in a form of space and time complexity, but you can do with the average. Now take a look at a simple algorithm for calculating the multiply of two numbers. You will now see how significant the space and time complexity is after understanding what they are. So start with the steps, like in a step 1 we start the program. In step 2, create two variables. You can take any variables. Here I take A and B. And the third step, store integers value in A and B as a input. You can, if you're writing in a C programming, you can take as a the value in a runtime with the help of scanf function. So after inserting the new values in a variables in a A and B, then go for the step number 4. Create a variable named multiply. Now after the applying a multiply, go for the step number 5. Store the multiply of A and B in a variable named multiply will give you output. So with the help of printf, you can display your result when you call the multiply keyword. With the help of that one, you can display the output. Finally, when you get the output, you can end your program, end your pseudo course with the help of AND operator. And in step number 6, you use AND keyword for the end the program. By this approach, you can calculate the multiplication operation. Now, how significant are space and time complexity? So basically, significant in term of time complexity, the input size has a storing relationship with time complexity. As the size of the input increases, so does the runtime or the amount of time it takes the algorithm to run. Here we can take a simple example, like assume you have a set of numbers like s equal to 10, 50, 20, 50 and 30. There are numerous algorithms for sorting the given numbers. However, not all of them are effective. To determine which is the most effective, you must perform computational analysis of each algorithm, because you have a lot of sorting technique to rearrange your data either in ascending order or in descending order. There are a lot of technique, already we discussed all the technique in the previous tutorials. So by the applying of all the sorting algorithm, you can rearrange your data in a ascending way, either in descending way. So which one you take, that is completely based on the time and space complexity. So here are some of the most critical findings from the graph. Like this test revealed the following sorting algorithm, like quick sort, insertion sort, bubble sort and heap sort and etc. You can use Python as the programming language or C as the programming language used to complete the task, and the input size range from 50 to 500 character. The result are follows. Heap sort algorithm performed well despite the length of the list. On the other hand, you discovered that insertion sort and bubble sort algorithm performed for worst case, significantly increasing computing time. Before you can run an analysis of an algorithm, you must first determine its stability. Understanding your data is the most important aspect of conducting a successful analysis. So, we already discussed these things in the previous tutorial. Now we understand the concept of asymptotic notation. Asymptotic notation are programming languages that allows you to analyze an algorithm running time by identifying its behavior and its input size grows. This is also referred to as an algorithm's growth rate. When the input size increases, does the algorithm becomes incredibly slow? Is the able to maintain its fast run time as the input size grows? You can answer this question thanks to asymptotic notation. You can compare two algorithms head to head. It is heavily influenced by the tools and hardware you use for the comparison, such as the operating system, CPU model, processors, generations, and so on. Even if you calculating time and space complexity for two algorithms running on the same system, these subtle changes in the system environment may affect their time and space complexity. As a result, you compare space and time complexity using asymptotic analysis. It compares two algorithms based on changes on their performance as the input size is increased or decreased. So, asymptotic notation are classified into three types. First one is big OH notation. We can denote by big OH by the O. Another one is big omega notation. We can denote it by that symbol omega. And the last one is a big theta notation. We can represent by the theta symbol. In a way, we can representing all the notation part. Now, we can understand notation one by one. So, in a big OH notation, so Mr. Paul invented the big O notation in 1894. Introduced this notation in this discussion of functions approximation. From the definition O of Gn, so here we find out the f of n. There exists positive constant c and number of such as that is O is less than or greater equal to f of n, and which where function of n is should be less than or equal to c of Gn, where c is a constant value. For all n should be greater than or equal to n of 0. So n denotes the upper bound values. If the function is O of n, it is also O of n square and O of n cube. It is the most widely used notation for asymptotic analysis. It specifies the upper bound of a function, the maximum time required by an algorithm or the worst case time complexity. In other words, it returns the highest possible output value in a big O for a given input. Now, we can understand the concept of big omega notation. Big omega is an asymptotic notation for the best case or a floor growth rate for a given function. It gives you an asymptotic lower bound on the growth rate of an algorithm runtime. From the definition, the function f of n is omega of g of n if there exist a positive numbers c and n, such that f of n should be a greater than or equal to c of Gn, where c is the constant part. For all small n are the greater or equal to the big N. Now we discuss the last notation, that is a big theta notation. In a big theta defines a function's lower and upper bounds. That means it exists as both most and at least boundaries for a given input values. From the definition, f of n is theta of Gn. If there exists positive number in a constant value like c1 and c2 and n such that c1 g of n is less than or equal to f of n, and f of n should be a less than or equal to c of the c2 of Gn. For all n should be a greater than or equal to a capital N. So by this we can understand the all type of cases like best case, worst case and average case in a asymptotic analysis. Best case, like it is defined as condition that allows an algorithm to complete statement execution in the shortest amount of time. In this case, the execution time serves as a lower bound on the algorithm time complexity. Suppose students sitting in the class and they are sitting according to the roll number. So the roll number 1 should be seated at the first bench. Now you start your searching operation and you having some work with the roll number 1 student. That then you go and enter the class and search the roll number 1 student, and that student particularly can seated at the first bench. You can find the roll number 1 at the first bench. So that is the worst case. Suppose the strength of the class is 50 and you having a work with the 25 student. Roll number 25 was to work to the row 25 student. To start the searching operation, like from the initialize the pointer 1, then you ask the student are you 25, then 2, 3, 4 like that, and you get the data at the in somewhere in the middle notation. So you can say that is the average case. And suppose you having identifying or searching any data item which is available and sitting at the last bench, and you start the searching operation, you will get data at the last node. So you can say that is the worst case. Worst case also a two type, either it will be successful, either it will be a not successful. If student is not available at that day, suppose he is absent at that day, so you can say you perform the searching operation, we will not get the data, but that is the worst case. The worst case either in a two way, either the success, either the unsuccess. So you can write in average case, you add the running time for each possible inputs combination and takes the average in the average case. Here the execution time serves as both a lower and upper bound on the algorithm time complexity. In a worst case, it is defined as the conditions that allows an algorithm to complete statement execution in the shortest amount of time possible. In this case, the execution time serves as an upper bound on the algorithm time complexity. You will now see how to calculate space and time complexity after grasping the significance of space and time complexity. Now, significance in terms of space complexity. Space complexity refers to the total amount of memory space used by an algorithm program, including the space of input values for executions. Calculating the space occupied by variables in the algorithm or program to determine space complexity. However, people frequently confuse space complexity with auxiliary space. Auxiliary space is simply extra or temporary space, and it is not the same as space complexity. To put it another way, auxiliary space or space used by input values are equal to the space complexity. When you merge both of the auxiliary space and space used by the input, that is represent the space complexity. The best algorithm or a program should have a low level of space complexity. The less space required, the faster it executes. So, method for calculating time complexity. To calculate the time complexity, you must consider each line of code in the program. Consider the multiplication function as an example. Now, calculate the time complexity of the multiply function. So, take a MUL as a multiply operation, applied some variables, then you start the applying any loop in a form of while, and while represented with I which is less than or equal to n, do write the operation like multiply equal to multiply by 1, that is, and increase the pointer I with the help of I equal to I plus 1, and there is a and while the condition up to the not satisfied, which to satisfy, the loop will be working when I will be greater than, so up to the n value, that way the loop will be break and end of the operation and display the multiply result. Let Tn be a function of the algorithm time complexity. Let's 1 and 2 have a time complexity of O of 1. Line 3 represent a loop. As a result, you must repeat lines 4 and 5 n minus 1 times. As a result, the time complexity of the lines 4 and 5 is O of n. Finally, adding the time complexity of all the lines, that overall time complexity of multiple functions, that is f of t n equals to O of n. The iterative methods gets its name because it calculates an iterative algorithm time complexity by parsing it line by line and adding the complexity. Aside from the iterative method, several other concepts are used in various cases. The recursive process, for example, is an excellent way to calculate the time complexity for recursion solution that used recursive tree or sub-situations. The Master's theorem is another popular method for calculating time complexity. Now we understand the concept of the space complexity. By the example, you will go over how to calculate space complexity. In this section, here is an example of computing the multiplication of array elements. Like you take one data type like a mul in a form of int and also take a I. So here you take a two variables in a form of I and multiply as a integer. Apply some loop like in the form of while, where I should be less than or equal to n. Then perform the operation like multiply. Whatever the result of multiply by the array of I. It means suppose you should array starting from the indexing I starting from the 0 up to the 5. So I increases one by one, and the array of that particular I, it means representing that particular item of that particular node. So node value will multiply by the multiple operation. Initially multiply is nothing. Now multiply with the help of array of I and back to the result into the multiply. Then again I will be incremented with the help of I equal to I plus 1, and the operation will be going on until and unless I is not greater, I will be not greater than up to the n. So final, when you calculating all the multiplying operation with the all the array values, then final result will be display and execute your program by the return of multiply. So final display, final operation of the all the data item will be multiplied together and finally display the result at the end of the program. So let's, S of n denotes the algorithm space complexity. In most system, an integer occupies 4 bytes of memory. As a result, the number of allocation bytes would be the space complexity. In a line 1, allocates memory space of 2 integers, resulting in S of n equal to 4 bytes, multiplied by 2 equal to 8 bytes. Line 2 represent a loop. Line 3 and 4 assigns a value to an already existing variables. As a result, there is no need to see aside any space. The return statement in the line 6 will allocate one more memory case. As a result, S of n equal to 4 times of, it means 2 plus 4, it means 12 bytes. Because the array is used in the algorithm to allocate n case of the integer, the final space complexity will be f of Sn is equals to n plus 12, that is equal to O of n. As you progress, though, this tutorial you will see some differences between the space and time complexity. So now you understand the difference between both of them. So you now understand the space and time complexity fundamentals and how to calculate it for an algorithm or program. In this section, you will summarize all previous discussion and list the key differences in a table. Let's understand. First, the difference between the time and space complexity are: in a time complexity, calculates the time required. In a space complexity, estimates the space memory required. In a time complexity, time is counted for all statement. In a space complexity, memory space is counted for all variables, inputs and outputs. In time complexity, the size of the input data is the primary determinant. in a space complexity primarily determined by the auxiliary variable size. In a time complexity, more crucial in terms of solution optimization, but in a space complexity, more essential in terms of solution optimization. So, now we understand the concept of algorithm analysis. So, algorithm analysis is usually performed at two stages: before implementation and after implementation. A prior analysis is the explanation of an algorithm theoretical analysis, assuming that all other variables such as processor speed are fixed and have no impact on implementations. An algorithm efficiency is determined. An algorithm empirical analysis is referred to as a posterior analysis. Programming language is used to carry out the selected algorithm. The chosen algorithm is then put to use on the intent computer system. Actual data such as running time and space requirement are gathered for the investigation. Now, algorithm complexity. If n is used to represent the size of the input data and x is assumed to represent an algorithm, then the efficiency of x is mostly influenced by how much time and space it takes to implement the method. In a time factor, the number of crucial operations such as comparisons in a sorting algorithm is counted or quantified to determine how much time has passed. In a space factor, the amount of space is determined or assessed by adding together how much memory the algorithm can use. When n is used as the size of the input data, the complexity of an algorithm f of n gives the amount of running time and or storage space required by the method. Now understand the factors which is affecting long-term uses of an algorithm. The following the factors that have crucial of an algorithm's long-term effectiveness, like efficiency. Efficiency plays a key role in developing a successful algorithm. Efficiency is what minimizes computation durations and delivers swift results. Next is finiteness. The algorithm must conclude predetermined number of steps. Otherwise it will consume more RAM and is not recommended. It is continuous through infinite loops or recursion. Stack overflow and out of bounds problem may happen. Next is correctness. Regardless of the magnitude of the input given, a good algorithm should generate a proper result. So these are the important factors of this one. Now we discuss the importance of time complexity and space complexity in the data structure in the real world. So in the real world, programmers are bound by the physical memory of the system on which they intend to run. This is where space complexity enters the picture because we never want to run a function or process that takes up more space than the system has available at any one time. On the other side, we don't want our operation to take too long, clogging and slowing down our apps. Now understand the efficiency of algorithm. Some algorithm performs better than other. We always prefer to select an efficient program, or we can say efficient algorithm. Hence matrices for assessing algorithm efficiency would be useful. The complexity of an algorithm is a function that describes the algorithm efficiency in terms of the amount of data it must process. There are usually natural units for the domain and range of this function. There are two basic complexity matrices of the efficiency of an algorithm. The time complexity is a function that describes how long an algorithm takes in terms of quantity of input it receives. The space complexity is a function that describes how much memory, or we can say space, an algorithm requires to the quantity of input to the method. Now we understand the applications of data structure. So the data structure is the core of software development. Any efficient method to a given problem is contingent on how effectively data is arranged. Hash tables are used to build identifier lookups in compiler implementations. The B-tree data structure are appropriate for use in database. The following are some of the most important areas where data structure are used. Like in artificial intelligence, data structure plays the important role in today's scenario that is called artificial intelligence. With the help of this one, artificial intelligence, right now we understand the concept of how we land the Chandrayaan-3 at the moon. So with the help of all the data structure, or we can say the artificial intelligence or data science, we can design that particular model to perfectly land on the moon. Next is compiler design. We can apply it with the help of data structure. We can design the compiler, how to compiler will check all the execution of the program. Next, we require a machine learning. Right now, all things are completely based on the machine. We can design the robots. Robots will take a decisions, how we can perform this situation, and lot of functions are really we can applicable in a medicines area, medicals area, in a force area, lot of area we can, by the machine learning, we can design a lot of things. So really data structure will be helpful for the machine learning. Next is database design and management. Next is blockchain. Blockchain is currently the technology is right now market is completely lot of the accounts and lot of things are focusing on the like blockchain technology, which is really powerful tools of the in today's world. Next is numerical and statistical analysis, operating system development, image and speech processing. Right now you can access, you can open your phones with the help of a speech recognition or an image technique. And the last one is the cryptography technique. You can convert your simple text into a cipher text with the help of cryptography technique, and that also comes under the data structure. So finally we can understand the benefits of the why we study this subject and what are the benefits of the learning of data structure. The actual reason behind your learning, you can improve your knowledge in the domain accordingly. For example, some people learn them particularly to suffix job interview, few to make their resumes to look better, etc. While other might learn to as competitive programmings, regardless of the reason for learning data structure and algorithm. There are benefits partitioning of to knowledge. The following are some of those benefits. Like this means that a programmer can write the correct code if they knew both data structure and algorithm. There can many different types of loop statement based on the desired outcomes. However, there are for core type, then they are like for loop, while loop, repeat, until, infinite looping we can use. So you can solve some real-time world complex problem also. Here you need to arrange and keep everything in such a structure that whatever you need to search something, you get that easily and as soon as possible. If you need find a book and algorithm from a library, you will go to the programming section first, then the algorithm book section. If these books are not organized in this manner and just described randomly, then it will be frustrating to find a specific book. So the data structure refer the way we organize information on your computer. Our computer scientists process and look for the best way we can organize the data we have, so it can be better processed based on the input provided. So knowing the many types of data structure available here adds the programmer in determining which the data structure is deal for solving an issue quickly. It's not only about getting an issue to work, it also about getting it to work efficiently. So today's tutorial, and for this complete course data structure using Z, I hope you understand the concept of this course as well as the tutorials, all the lectures. So all the best for your better understanding of all the subjects for this one. Thank you.